Solution. Since the Pythagoras theory states that the square root of the hypotenuse is equal to the sum of the square root of the two sides of a right angle triangle, the resultant displacement r of the triangle can be found by getting r squared is equal to 300 squared of the distance covered from Calabar to Ilorin at a 30 degrees centigrade plus the distance flow from Ilorin to Kano, 400 kilometers, which will now give us the square root of resistance, which equals to 90,000 plus 160,000, which will now give us, to get the square root, the displacement, we now make the square to go over to the other side to become a square root, which will now give us square root of 250,000, which will give us 500 kilometers. And let's go to another chapter 1.2. We'll be looking at motion, but under this motion we have the friction and the circular motion. Then let's start by looking into the friction. Coefficient of static friction U, mu, is the ratio of the limiting frictional force F to the normal reaction R. That is, limiting frictional force F over normal reaction will now give us mu, a constant, which is a constant. For inclined plane, we have that the coefficient of static friction mu is equal to limiting frictional force F over normal reaction, which is also equal to mg sin theta over mg cos theta, which will give us tan theta. Resolution of forces on an inclined plane. Figure 1.4 illustrates where mg sin theta is force pulling the mass A down the plane. F is the resistance dragging it. Rho is the reaction. Mg sin cos theta is the force of gravity at an angle theta. At normal, mg sin is the distance covered. Example 4. A plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60%. Calculate the force parallel to the inclined plane. According to figure 1.5 example, a force pulling the mass 12 kg down the plane is F. The resistance dragging it. A force pulling the mass 12 kg down the plane is F. The resistance dragging it is R. The reaction is mg cos theta. Is the force of gravity at an angle of 30 degrees at normal. Force in an inclined plane, we have coefficient of static friction mu equals to limiting frictional force over normal reaction, which is equals to mg sin theta over mg cos theta. But reaction is equals to mg cos theta, which is equals to 120 cos 30 degrees. But coefficient of static friction mu, or the efficiency, is 60%, which is equals to 0.6. Frictional force F is equals to mu R, which is equals to 120 cos 30 times 0.6, which we have equals to 120 times 0.88 of 0.866 times 0.6, which will give us 62.35 Newton. Weight up the plane is equals to mg sin theta, which will give us 120 sin 30 degrees, which will give us 60 Newton. Force parallel to the plane required just push up the load will now give us 62.352 plus 60 will now give us 122.352 Newton. Example 2. A body of mass 6 kg rests on an inclined plane. The normal reaction is R and the limiting frictional force is F, as shown in the diagram. If F is 30 Newton and 10 is equal to force of gravity, then calculate the angle of inclination theta, where mg sin theta is the force pulling the mass down the plane. F is the resistance dragging it. Rho is the reaction. Mg cos theta is the force of gravity at an angle theta at the normal. Mg sin theta is the distance covered. Solution. Weight of the body is equal to 6 mass, which is mass, times 10, which is force of gravity, which will give us 60 Newton. Since the body is at rest, force of friction is equal to weight sin theta. That is 60 sin theta will give us 30 Newton. Sin theta is equal to 30 over 60, which will give us 0.5. Sine inverse of 0.5 to get theta will give us 30 degrees. Therefore, the angle of inclination is 30 degrees. Example 3. If the mass of the trolley is 0.1 kg, calculate the weight of plasticine that is needed to compensate friction. Take gravitation equals to 10 meters per second squared and coefficient of friction mu equals to 0.2. Solution. Normal reaction R is equals to mg, which is equals to 0.1 times 10 Newton. Coefficient of friction is equals to 0.2, but limiting frictional force over normal reaction R is equals to coefficient of friction mu, where F is the limiting frictional force. F is now equal to, making F the subject of the formula, we now have mu R, which is equal to 0.2 times, in bracket, 0.1 times 10, close bracket, which will now give us 0.2 Newton. Weight of the plasticine needed to compensate friction is now equal to 0.2 Newton. Figure 1.7 example. The diagram above shows a body resting on an inclined plane. If the body slides down the plane, what will be its acceleration? Take force of gravity G equal to 10 meters per second squared. Solution. Since the body slides down the plane, the resultant force acts down the inclined plane. Mass times acceleration due to gravity G sin theta minus 25 is equal to mass times acceleration according to second Newton's law. 15 of the mass times 10 of the acceleration due to gravity sin 30 degrees of the inclined plane minus 25 is equals to mass, which is 15 times A. 150 times 1 over 2 minus 25 is equals to 15A. Therefore, A is equals to 75 minus 25 over 15, which will now give us 50 over 15, which will give us 3.3 meters per second square. Its acceleration is therefore 3.3 meters per second square. Example 5.